In order to be successful on day 3, we have to utilize a switch from rational exponents to radical form. Rational exponents are fractional exponents, and of course your radical is here. There's a relationship between the exponent and the radical itself, and that relationship is symbolized here. The numerator of the fraction stays on the exponent. The denominator of the fraction becomes the index value of the radical. So in this case, when we're converting between radical to rational exponent notation, we simply identify this and make the switch. X to the 7/4 power. This is a 1 on your x, so that's x to the 1. And your 4 becomes the denominator. Now this is one of the few times in mathematics where if it's not written, it's not 1 or 0. So remember, what we're dealing with here is a square root. A square root symbol involves the number 2. So remember that the index value of a square root is not 1, it's actually 2. So when switching this to rational exponent form, we're going to do 5/2. And remember, this one is 16 to the 1/2 power. Okay, now it's valuable that you understand that 16 to the 1/2 power is the same as the square root of 16, because otherwise this simply reduces to 4. But you will see it in rational exponent form, and if you're not familiar with the switch, then it's confusing to you to see that. Alright, now we'll switch back into the other form. Remember, the numerator stays on the exponent, the denominator becomes the index of the radical. So that's the 3rd root of x squared. Like I said, this right here is the same as saying the square root of 100, which is 10. Every once in a while, test writers like to throw in nonsensical items, so we'll simply place all of these strange symbols in their appropriate place from one form to the other. Okay? Alright, now we are going to simplify the following using rational exponents and switching them to radical. Here we'll be changing this back into radical form, and it is the cubic root of 8. Negative 8 will give you the negative 2. This one, including the negative sign, we're going to have to make sure we understand what we're looking at here. First things first, I'm going to switch it into radical form, so it's the square root of 121 to the negative 1 power, and then I'm going to draw my fraction bar within the radical and write it as 1/121. The square root of 121 is 11, so the answer to this question is 1/11. Negative 16 to the 1/4 power. Now this one's a little bit tricky because there is no parentheses around it. We're going to treat these as two different values. Notice the subtle difference between this and what is actually written. So be very careful, and let's assume that since there's no parentheses, that these are two different numbers. So we're going to go negative 4th root of 16 to the 1st power. So the 4th root of 16 is 2, and the resulting answer is negative 2. Please note that this value is undefined because we cannot have a negative inside a radical that has an index of an even number. So we'll go ahead and rewrite this one as the cubic root of 8 squared. 8 squared is 64, so the cubic root of 64 is 4. Number 12, we're going to have to distribute this. We're going to have to rewrite this without distributing it. It's a lot easier that way. So it's going to be 4x squared to the 3rd power inside of a square root symbol. So we're going to distribute the 3 inside, and we get the square root of 64 x to the 6th power. Now we'll go ahead and simplify 64. That's going to be 8. And if I write out my x's, 1, 2, 3, 4, 5, 6, and circle my pairs of them, I get x to the 3rd. And there's my final answer. Alright, I'll go ahead and solve this one. The 27 squared, and then the cubic root of 27 squared ends up being 9. Just like before, we'll rewrite it as 125 to the negative 2 power, and we'll put that inside a radical with an index of 3. And we'll move this to the denominator of the fraction, so that's 1 over 125 squared. And that's going to be 1 over 25. Now we're getting a little bit more complicated with our numbers involving variables and fractions at the same time. So it's going to be r squared t to the 3rd divided by t to the 3/4 power. It's easier to manipulate these because now we can incorporate properties of exponents. We'll subtract those two from each other. The common denominator is 4. That's 12 over 4. 12 minus 3 is 9. So our final answer is going to be r squared t to the 9 over 4 power. Now depending on which one they want you to leave it in, you could simply change it back into a radical and have it as 4 as the index, t to the 9th inside as the radicand. Alright, we're going to distribute this into there, and we're going to get 12 over 72. And that reduces to 1/6, so w to the 1/6 rational exponent, or the 6th root of w to the 1st as a radical. Alright, we're going to distribute this in to all of these numbers. And we get n to the 4th divided by x to the 50th, n to the negative 2. I'm going to rewrite this with my n's up top because this negative must move to the top. n4 n squared x 50, and that's going to give me n to the 6th power divided by x to the 50th. So in looking at this, we've got a radical inside of a radical, so let's go ahead and deal with them separately. And that's going to be 27 to the 1/2 power. And then we're going to make this 27 to the 1/2 power, and then we have to raise that to the 1/3 power, and that's how we get 1/6. 27 to the 1/6 power is your answer here. In looking at this, all we're doing is substituting negative 8 in here. So f of x equals negative 8 to the 2/3 power plus x to negative 8 to the negative 3rd power. And that becomes a simple calculation problem after you've done that.